So we're going to look at equivalent fractions. Well, for us to be able to compare fractions, we have to make sure that all of our wholes are the same size. If our wholes are not the same size, then we cannot compare fractions. So you'll notice that each of these fraction bars, they're all about the same length. I did hand draw them, so they're not perfect, but they are about the same size. So this whole is worth the same amount as this whole, and this one, and this one. They're all the same. So we can compare them. Now this whole is split up into how many parts? What would our denominator be to tell us how many parts that this is split up into? The way we can tell that is by counting the number of parts. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So this whole is split into 12 parts. Therefore, my denominator is 12. This whole is split into how many parts? Visually, it's very easy to see. It is split into 4 parts. So therefore, my denominator is 4. This whole, 2 parts. This whole, 3 parts. And this whole, 6 parts. So if I was to name these, 12 parts, twelfths. 4 parts, fourths. 2 parts, halves. 3 parts, thirds. 6 parts, sixths. So these mean that it takes 6 parts to equal 1 whole. 3 parts to equal 1 whole. 2 parts for 1 whole, 4 parts for 1 whole, 12 parts for 1 whole. So if we had since we have 1 whole, what would my numerator be for each of these? 12 twelfths is 1 whole. 4 fourths is 1 whole. 2 halves, 1 whole. 3 thirds, 1 whole. 6 sixths, 1 whole. What does this line mean? Divided by. This line on every single one of these, this fraction line means divided by. So 12 divided by 12 equals 1, because anything divided by itself equals 1. 4 divided by 4, 1. 2 divided by 2, 1. You got it. So anything divided by itself is 1. So that means that these are all equal to 1 whole. So now we want to look at what equivalent fractions mean. So looking at these, notice that this line matches up with this line. This one matches up with this one, and it matches up with this one, and it also matches up with that one. So that means that because they take up the same amount of space, they are equivalent. So if I was to shade in these 3 here, how many did I shade in? I shaded in 3 twelfths. And that takes up the exact same amount of room as this. And how much did I shade in here? I shaded in 1 fourth. Therefore, 3 twelfths is equivalent to 1 fourth because the wholes are the same size and it takes up the same amount of space in each whole. What if I take it a little bit further? If I shade in those 3 twelfths plus another 3 twelfths, how many twelfths have I shaded in now? I have shaded in 6 twelfths. 6 twelfths is equivalent to me shading in 1 more fourth. So how many fourths have I shaded in? I shaded in 1 fourth, and now I've shaded in 2 fourths. And I probably should have put this 3 twelfths right here above that. And the 1 fourth right here above that. And if I shade in on my halves, how much have I shaded in? I've shaded in 1 of those halves. So 1 half is equivalent to 2 fourths, which is also equivalent to 6 twelfths. And if I go down and look at this sixths, I notice that that ends right there. And if I shade all the way up to that line, how many sixths did I have shaded in? 1/6, 2/6, 3/6. Therefore, 3/6 is equivalent to 1/2. So that is how equivalent fractions work. Same size wholes, and figure out if they take up the same amount of space. And it's easiest to compare fractions by drawing fraction bars rather than circles. Circles can be very challenging to draw equal size pieces.